Good morning, Data 100. Welcome to the largest upper division course at UC Berkeley. This is very exciting. Before we get started, I would like to ask everyone to either find a seat or please leave the lecture hall because of the fire code. And you should be able to join over Zoom and then watch it synchronously with us. And maybe next time we'll try to find a way to accommodate most people. There are some seats over here, there's some in the back, and I see like a cluster of a small number of seats here. So either find a seat or please leave the lecture. And I'm sorry about that. This is kind of one part of the perk of having a large course, and this is the largest kind of lecture hall that we could get. All right. So you saw a few QR codes that was posted online. Please go ahead and scan this QR code. This is a Slido platform that we're using for doing lecture attendance. If you're on your phone, scan it. If you're on your laptop, just go to slido.com and then type in those digits, and you should be able to get in and then see all the polls that we're posting. This is also where you can ask questions, and our wonderful TAs are here to respond to questions that you might have in a synchronous way. So let's see if that's been working or not. What emoji best describes your mood today? Give me something exciting. Not so exciting, but like something that like it looks happy. Oh, it's not showing. All right, let me make sure that you can see the poll results. Data 100. The results. Let me reload this. No. Okay, sometimes it might not cooperate, but we'll try to work with it.
Next slide.
Okay, good. So we're here, and let's give this a try one more time. Oh no. Thought it was working fine. But you should be able to see the results on your phone and on your laptop. I'm just trying to fix this. Wonderful, it's rendering technology. So you should be able to see that. Give me one sec. All right. Cool. Anyhow, so you're seeing that on the left-hand side, there's 11 participants still typing, and on the right-hand side, you're seeing that 637 of you roughly responded to this. This is how we're going to do class participation. So in any of the lectures, if you respond to one of the polls, that accounts for like you being present synchronously. And then I'm going to talk about what's the general lecture participation policy is a little bit later. So in all of the slides that you'll see in Data 100, the QR code and the code for Slido is going to be on the top right. So anytime that you join in the lecture, you don't need to be here in the beginning, but you should be able to sign in and sign out anytime that you want during the lecture to ask questions. So the plan for today is that we're going to do intro. We're going to go over what data science is. We're going to go over data science lifecycle. We're going to see a quick demo, and then you'll get a sense of what are the students that we have in Data 100 and kind of see the majors, see the names and whatnot. And the data is kind of anonymized, but we'll be able to see a fun demo. And we're going to go over some kind of fun things that we're going to go over some logistics. And we'll read the syllabus, at least part of the syllabus together. So before I hand it over to Joey, let me introduce myself. My name is Nargis Nourouzi. I'm an assistant teaching professor in the EECS department. I joined Berkeley in 2012. Before that, I was at Santa Cruz as a faculty member since 2017. And before that, I did my PhD at University of Toronto in artificial perception lab. So my training is mostly in the statistical signal processing applied to machine learning and in biomedical domain. Since I joined Berkeley, I switched gears a little bit, and now I'm more focused on intelligent AI tutoring systems and how we can incorporate AI in education. So this semester I'm teaching Data 100. This is the fourth time that I'm teaching the course. And then I'm also teaching 2 other research seminar courses in EECS. So that's what I'll be doing. And then what I have is also that I hold office hours both in my office and also in Barn Hall. So I'm looking forward to meeting you all in either of the office hours to chat and get to know you all a little bit better. I'll come back in the second half and I'll hand it over to Joey.
Hello, everyone. Can we lower that? Nope. Okay. One more time. All right. Can you hear me now?
Lecture run. It's fine.
The mics. Right. Take 2. Hello, everyone. That's better. All right. We need these to be recorded, so I have 2 mics on me. So hi, my name is Joey Gonzalez. I'm one of the co-instructors of Data 100. A little bit of my background. So I did my undergraduate studies at Caltech long ago. Maybe before some of you were born? No, that's crazy. A long time ago. Different environment. But a lot of what we will do in this class has, the same kind of underpinnings of the sciences that you will see, in data science. I did my PhD at Carnegie Mellon, again, really long ago. My research has been in the study of parallel and distributed algorithms for statistical inference. At least that's what it was. I came to Berkeley 2016. And since then, I've run a couple of the major labs at Berkeley that work at the intersection of AI and systems. So my focus, if you call that, is AI systems. I put links to a lot of different kinds of research projects I do on this slide. I will say in my office hours, half my office hours, people come in and don't talk about the class at all. Instead, they talk about research, what's going on in Gen AI. I do a lot of work in Gen AI today. My lab runs some of the biggest open Gen AI programs in the world. So we run the systems that everyone now goes to figure out what is the best model today. So the chatbot arena. We run the software frameworks that serve most of the open source models in production. We also, in my group, do a lot of research in kind of computer vision, interaction of Gen AI, and kind of reasoning about things like human behavior. So a lot of really cool stuff in the Gen AI space. I also have some entrepreneurial activities outside of Berkeley. So I co-founded a few companies. I'm advisors to several others working in AI and data science. And actually, this entrepreneurial stuff that I've been doing has been a lot of fun because I got to speak to hundreds of data scientists for the past 5 years in a broad array of industries to understand what they are doing and what we are teaching and how it aligns. And the good news I can say with confidence, what we're teaching in this class is very relevant to what people are doing in the real world today. All right, so I also teach Data 100. I taught the first one. In fact, I created the first Data 100. It was a disaster. That was V0. V1 was also not great. V2 got better. And over time, it improved. I took a break, and professionals that know what they're doing took over the class, and it is now a much better class. So I got to teach again with Professor Nourouzi last semester, and it has come a very long way. It is a well-organized, efficient class. Students learn well and generally enjoy the class. So our teaching reviews have gone up substantially since the early days of Data 100. I also teach a graduate systems class, and for the first time ever, I'm teaching both at the same time. So my office hours I'm going to make open to some of the graduate students coming in too, so they might also come in and talk about some of the research that they're doing in AI systems. Another important detail about me, I have 2 little kids, and I have to pick them up at 5 o'clock sharp, or the daycare gets really mad at me. And so in office hours, when I say gotta go, I really gotta go. And in fact, if I'm there and it's 5 o'clock and I haven't left, you need to tell me you gotta go. So it's office hours ends at 5 o'clock sharp. Okay. So what is data science? When we started teaching this class, that was the big question, actually. People are like, what is it to teach data science? What is the curriculum? What does it really mean to be a data scientist? There are all these comical definitions. I think for us, it was helpful to start thinking about what people were doing that were called data scientists. And when I do that, I think we also see where the field has evolved over the years that we've been building this class, and also maybe where you all are headed when you graduate. So when we started this journey of building a data science program at Berkeley, the hot things that data scientists were doing were transforming how people interacted with content, with advertising. All of Google, Facebook, I guess Meta, Netflix were driven by algorithms that were making decisions about what to see. It's still true today. Things like TikTok rely heavily on these algorithms. And the people designing these technologies are often the data scientists. And so that's where we started. We had in Data 8, DJ Patel as a lecturer. DJ is one of the people who actually coined the term data scientist. He coined it to try to define the kind of scientific essence of what they were doing at LinkedIn at the time, studying large amounts of data, trying to make decisions about who should work for who, building connections in a big social graph. He was then the first data scientist for the US government. He was hired by the Obama administration to run data science. And I've linked to the video lecture he gave. It's amazing. So data scientists became the first responders for the Obama administration. Something goes wrong, who are you going to call? Not the Army, not the police, the data scientists. Why? Why would Obama pull a data scientist first? What's wrong? It was often a hard question of like, I don't understand the problem. There's a virus, there's a wildfire, there's a national disaster, there's a flood. Data scientists were called in to look at what we know about that place, what data we have, and what things do we need to prioritize right away. And so data scientists were put in an emergency situation frequently, which is kind of crazy. So, as a data scientist, you might think you're going to sit behind a computer and think slowly. You might be, the first responder for the next national disaster. Speaking of disasters, another place where data science plays a big role in California is in wildfire management. So there's a big fire. You'd be surprised how little information we actually have about where the fire is or where it's going. We have aggregate weather reports, but if we really want to be able to predict where we need to route first responders, where we need to apply water or fire suppressant, we need to understand the terrain, we need to understand how fire propagates through different kinds of trees. These are complex questions that take the data we've collected over time to make very important decisions about how to manage a fire. Maybe the last three I'll talk about. Black holes. Data scientists are also helping us see what a black hole looks like. What does a black hole look like? It's hard to see. Light doesn't leave it. So there's a bunch of technology to develop to take sparse data about signals from a black hole or signals around a black hole, and then using ideas that we'll actually cover in this class, developing algorithms to take those signals and turn them into the first picture of a black hole. So the sparse recovery algorithms that we will cover here are the same kinds of techniques being used to solve these problems. What's kind of neat about this is we have to use our prior knowledge because we don't have all the information. So this study was saying, if I assume black holes were actually snowmen, what would happen if I ran that actual image through these algorithms? And some algorithms, have this prior knowledge, it should be a hole, and they inject a hole in the picture even though there isn't one. Others try to preserve the underlying signal. There's a big question in data science how we use our assumptions, but it's also critical in fundamental science how we use those assumptions. And this is what we do, I guess, every day with data science. All right. So hopefully I've given some examples of the places you use data science. At this point, having talked to many people in data science, no matter what industry you're in, if you're selling fancy soap, I've talked to data scientists that work at that company. If you're selling routing systems for managing drones in the future, data scientists working at that company too. If you're doing stuff that works with data today, you likely will have someone in a data science capacity at that organization. So it's a pretty exciting high impact area. Why does it matter? The world is complicated, and we often have to make these kinds of hard decisions with limited information. Data science is used in all of these settings to help make these decisions. In science, as I said, is black holes. In medicine, you're trying to treat a disease or understand how a treatment is working using data science. Social sciences, the foundation of data science came from studying social networks. Engineering, you're designing a new product and you want to know failure modes and what you can say about the signals you've heard from the field. Is the product broken? Sports, anyone betting on sports? The whole field of sports today relies on data science to make decisions about who to invest in, what programs are working and what are not. One of the things that's kind of neat, and maybe also a little bit dangerous, is today a lot of people say, well, the data says. And that's like, well, how do you argue with the data? The data says something, it must be true. But the data doesn't really get to say much at all. It's what we interpret from the data. It's not always easy to tell what the data says. And through this class, hopefully you will build the skills to go, well, I'm going to ask the data myself. I'm going to try to understand what the data is trying to say. And it may not always be what others tell you the data says. Right? So we live in a world that depends so heavily on data. Understanding how to reason about that data is critical. I made this slide, I think the fourth time I taught this class, maybe 2020, yeah, 2021. I was looking at the evolution of technology, the whole field. In the 1980s, we were building hardware. You could sell a box. You got a box you put on your desk, and you buy a big box for your office. It was all about the box. Then the software industry came along and said, we don't need boxes. It's really about the software. It's a disk now. We'll put that in your computer. We'll sell that. And then technology evolved some more. We built on top of that software, the internet. Who needs software? Who's installed software? Maybe you occasionally download some apps, but the reality is you're downloading it from the internet, you're interacting with the external world, right? Software isn't about what's on your box or on your phone, it's what's in the web. And that opened up this data industry. Everyone's now connected. Your photos, everything you're doing is being put online. So that gave us all this data. And that is what created the whole data science excitement, is now have all of this data, what can we say? So what is 2020 going to be? What do you think? I made a big bet in 2021. This is going to be the decade of AI. I was so right. This is the decade of AI. Much more than we maybe had thought, more than I had thought at that point in time. So AI is changing everything. What's kind of crazy about AI, especially the AI that we're using now, these generative models, is they're built on basic ideas from here. Just push much bigger, much, much bigger. And they're also transforming. The role of the algorithm isn't as critical anymore. There's one magic black box, and it's the data again that matters. And it's how we interpret the connection of that box to the data that matters. So it's putting a lot more power back in this kind of interaction with the data and the understanding that it might reveal. So we'll talk about Gen AI towards the end of the class. As I said, I'm happy to talk about it as much as you all want in office hours. And Professor Neruzzi is also doing a lot in this space. You should talk to her about it as well in office hours. When we started teaching this class, there was also a fear around what are the downsides of data science. There's a pretty good book that talked about the weapons of math destruction. And it pointed out a problem that was emerging. That we're building these really complex things. They're hard to understand, hard to reason about, and they're making big decisions. Stock market crashing because mortgage-backed securities we don't understand. Teaching scores. My teaching scores, job achievement, all these things being evaluated by algorithms that were opaque. And so how do I improve my teaching if I don't know what's going on? How do I invest in a market that I don't understand? Sentencing, making decisions about who stays in jail and who doesn't, based on black box things that people don't understand. Is that okay to use all this technology that really maybe could make a difference, maybe make better decisions, but also makes it harder to see what's going on, that makes the thought process more opaque? As data science today, your job isn't just to make it a good decision, it's to communicate why that decision makes sense. It's to provide clarity in these technologies. You're going to use things that are going to seem opaque, but you need to be able to communicate why those things helped you make the decision you made. So we'll talk about that in this class as well. The ethics of data science in these technologies. But I decided to teach the class anyways. I decided to push the program anyways. And that's because I'm very optimistic. These technologies, these ideas are very empowering. So there's immense potential to address the challenges facing society, and you all need those skills. So the future is in your hands, and you will use this knowledge, these skills for good. So that is why I am excited to teach Data 100 and why the Data 100 program, I think, has been very successful. One of the kind of neat things about data science that differentiates it from a lot of the other engineering disciplines is it's also very human-centric. We need to understand not just the technology, the algorithms, the systems, the compute, the math. We also need to understand its connection to society. We need to do this by thinking critically. So to quantify things, to understand things reliably, we need to be able to find relevant information. That means understanding the problem domain, not just the database. It means recognizing the limitations of the data you have. What's wrong with the data I got? Often quite a bit. It means asking the right questions. Someone says, how do we increase success of our product? And you might go, well, it's not the product that's the issue, it's support. What's wrong with support? Being able to ask the right questions is critical, and that again requires understanding the domain. You're going to have to make assumptions. Making sure those assumptions are reasonable, important. How do you conduct appropriate analysis? We'll teach you some of those techniques in this class, but you'll have to learn more. How you analyze things will change. It'll depend on what you're doing. And I said this earlier, but it's critical. You can't just go, the p-value is this. Here's the number. You need to explain. How did you come to those conclusions? What does that say? Synthesize what you have and provide insights that other people can understand. This whole thing relies on critical thinking, skepticism, and understanding the domain. And also understanding how that decision you make will affect others. Because those trade-offs will affect your assumptions and how you approach both the technical side of the problem and also how you communicate the results. Bold claim, but after this course, you should be able to take data and produce useful insights. The world's most challenging problems and most challenging and ambiguous problems. That is true. And I'll talk about that in a moment. We built this course to make sure that it would be useful to you on several dimensions. All right, so I still haven't said what data science is, because it's a silly thing to ask, but let's do it. What is data science? The going definition, which a pictorial definition, this is the Drew Conway's Venn diagram of data science, is that it's the combination of a few sets of skills. I'll call this statistics, mathematics and statistics. Hacking skills, that's offensive. Computer science over here. And then substantive expertise, so knowing the domain. I'm applying data science in fashion. I need to understand fashion. I can't just be the computer scientist or the statistician. And there's some jokes that if you understand the domain and computer science but don't understand statistics, that's pretty dangerous. That's true. You need to understand the consequences of uncertainty in your data. For a while, the people who did statistics and computer science but knew nothing else were machine learning experts. And then traditional research people, people who would have been hired as an analyst in the past, had a statistics background, knew the domain, but didn't have the computational skills to really dig into the data at the scale and the sophistication that a modern data scientist would. So I wrote my own definition. I like this one. And then everyone keeps using my picture on the slide, but all right. Data science is the application of data-centric, computational, and inferential thinking, I should explain that in a moment, to understand the world. It's the science, and to solve problems, engineering. There is an engineering and a science to data science. And we'll cover both in this class. And we'll talk about what it means to be data-centric thinking. I have a problem. What's the data? Data-centric thinking. Computational thinking. How can I use computation to manage my uncertainty, to understand the data better and do it efficiently? And inferential thinking, understanding what I don't understand and trying to draw conclusions about what I don't understand from what I do. It's an out-of-date picture, but it's still relatively accurate. What do data scientists do? I used to zoom in on this, but I'll just point at some high points. And this is a survey of 2016 data scientists. And at that point in time, and I still think this is true today, most data scientists were doing things like exploratory data analysis, which is a large part of this class. How do I take a big set of data and understand what it's telling me, what it wants to tell me, maybe what I should have asked, what data I'm missing? A lot of interview questions still have the flavor of, here's a laptop with some interesting data in this folder. Tell me something. You have 30 minutes. what do you do? How do you go through that process? Data cleaning used to be a big part of data science. Technology has come a long way. You'll do some data cleaning, but the reality is that data is getting easier and easier to work with from the beginning, which is great news. All this cool machine learning stuff, 39% of people said they were doing some degree of, or I guess here, 36% of people said they were doing some degree of this machine learning work on a daily basis. I think now you'll probably use more and more machine learning because it's become so much easier. So you'll see more of that, and we'll cover that in this class. Yeah. So a good question, why is data cleaning less relevant? We'll get to more of that in the course, but short answer is that the technologies we use to manage data have come a long way, and people have become better at adopting more principled data management strategies for all of their data. You'll see I talk a little about the database side of the world too. I do some work in database systems, so it'll leak into the class. My apologies. Put this slide up because there's a lot of excitement from the engineering crowd, that's me, about data science is all about these really cool algorithms and software and systems and computing. And it is. You do need to understand these technologies. It's important to be able to use these skills. But it's only as good as the insights you draw. It isn't just about the numbers. So you're going to have to do thinking too. It's not just going to be about computing. Though you will do a lot of computing. So in the past, we went deeper on the kinds of questions you kind of explore as a data scientist. Maybe I'll just highlight a few. You guys can read this on your own. As a business, we were hit on what things should I recommend. Businesses rely heavily on data science to understand how their business is going, how it's performing, where to improve things now, like sales, support. All that is now analyzed by data science teams. Governments are hiring data scientists around the world to answer big questions. Again, they have data from many different sources. That is messier. Bringing all that data together and trying to answer questions about where their economies are going, where they need to make investments is critical. And then you might use data science in your everyday life. I am not joking. When my daughter was born, I didn't have a name for her because I was busy working in a Jupyter notebook trying to find what girl's name would be good, short, but not too common. And so I had a whole statistical model of a distribution of names. We ended up with Nora, which I was excited about. It was short. It was relatively common, but not too common. Unfortunately, it became more common right after we picked it. So try to predict the future. But yeah, you might use data science in your everyday life. And hopefully after this class, there'll be something, yeah, I'll go look at the data and figure that out. What will you learn in this class? So principles and techniques. That pretty much sums it up. We're going to teach some big ideas and a lot of, here's how to do it, getting in the weeds. These course goals we wrote before we came up with the curriculum for the class. And I stand by them. There are three, and I think all three matter. First, prepare. We want to prepare students for advanced Berkeley courses in data management, machine learning, and statistics, and human context and ethics. We need to update this by providing the necessary foundation and context. This is critical. And all the upper-div classes, you need to make sure they cover these things in your class. And so we've tried our best to make sure that we built the tools that you need to go on and take upper division classes and do well. This was important for me. I want to enable students to start careers as data scientists by providing experience working with real-world data tools and techniques. After this class, you should be able to do stuff. It's not just a theory class. And I've actually heard many students who take this class, went on to do internships, or go off, take no other classes and go off in the industry and become data scientists. This class was helpful for them. Hopefully it will remain helpful for you. And then empower. I like this one. Empower students to apply computational inferential thinking to address real-world problems in their lives as well. So you should come away from this class going, yeah, I'm going to do that. I'm not going to just stand by and let the data speak to someone else. I will talk to the data myself. Here's a tentative list of topics. This is not tentative. We're going to cover these topics, and I'm not going to change the class. In the past, I've made changes to the class. It's always been bad. So we're going to just stick with the topics that are on the slide. I think it's pretty accurate. All right. We have a Slido. Is it working now? We'll restart it. This is always fun. Which of these topics excite you most? Please rank. I assume you see them. I'm going to refresh this. Refresh. Lead slide work. No, this is usually a lot of fun. Let me try it. Can we just go to, oh, click.
Magic.
Okay. All right, so what do people want to learn? Applications of data science. We'll cover that. Data visualization techniques, we'll do a lot of that. Exploratory data analysis, we'll do a lot of that. There's anything here we're not doing? Dimensionality reduction, we're going to do that. I did that in the past, it was complicated. We'll make it less complicated this time. We'll do a fair amount of linear regression, classification. Yeah, excellent. So your expectations align very much with what you will be doing throughout the class as well. This is a pretty good balance of the amount of focus in the material. Do we take it? All right. Thank you all. Yep. We have 2 minutes. Yeah, I'm going to turn it off.
All right, hello again. So let's go over some less fun things, and then we'll basically afterwards switch to the most fun part of the lecture. We're gonna see a quick demo. So let's see, prereqs for the course. So you know that Data 100 will enforce prereqs strictly. So students who are in Data 100, they come with Data A. The students in Data 200, 200S, 200A, you can just enroll in the course without taking Data A. There are other prereqs, like there's programming prereq that you have to satisfy, and there is also a linear algebra requirement. So with the linear algebra requirement, you all know that it's a co-req with the course, not a prereq. So as the way that the course is structured is that we need linear algebra in kind of the second half of the course. So by the time that we hit linear algebra stuff, you have learned enough in your linear algebra course that you should be comfortable. But there are also resources that we shared on Ed that you can go ahead and study ahead of your linear algebra course so that you're more comfortable with Data 100 stuff. So let's go over some course overview. And before I go into more logistics, I want to introduce our wonderful staff. This huge course obviously doesn't run itself. So we have wonderful leads in the course. So I would like to introduce your head TAs, Shreya and Angela. Stand up, wave. They have started working on the course about a month before. So everything that you're seeing, all the infrastructure that are set up, is the great work of all of the head TAs and the leads that we have. Thank you so much. We also have Sarah, who is the lecture lead here. Anish is our student support lead. I don't know if Anish is here. Malavita is not here, but she is our infrastructure lead. Abby, stand up, please. Wonderful. So Abby is our data scholars lead. And Dan, wonderful. Dan is our staff support lead. So we have a lead that leads all the UCS ones and make kind of the coordination of the course much easier. Rose and Jessica are our graduate student TAs who are going to work with Data 200 students and also with the content team. Brandon is here. Brandon is working on exams and some resources that you can use for exams. And Sam, I don't think that Sam is here. Sam, you're going to see Sam a lot on Ed. He's handling all the logistics of the course, which is a lot. And Prableen is our content lead. I miss Prableen. Prableen is not here. So most of our staff are returning staff, so they're pretty experienced and super dependable staff that we have this semester. We also have UCS2s. So UCS2s, you're going to meet with them in discussions and in some office hours. So their names are also listed here. And we also have a group of UCS1s. I think at least Meenakshi is here. Meenakshi is gonna, you're gonna see Meenakshi in lecture, and then you're gonna also see her on Ed a lot. And we also have a large team of UCS1s that you'll see them in office hours, and you're also gonna see them on Ed as well. So a little bit about course logistics. So what I'm going to do is I'm going to actually fly through the syllabus pretty quickly. It's going to be fast, but if you give it a read another time, it will all make sense to you. About Data 100 and the goal of Data 100 and learning objectives and all of those things, you're already familiar with it. There is a specific language around course culture. Data 100 is the most diverse and one of the largest upper division courses on campus. So we would like to ask you to be mindful when you're interacting with your fellow classmates and with the TAs and be respectful in all of your interactions. If any issues came up, please reach out to us and please also reach out to DSUS office and all of those information and the Google Forms that you can fill out and report things anonymously is linked on the syllabus here as well. So I'm gonna scroll over and then get to the course component. So what you're seeing here is a pretty standard week in Data 100. How would your week look like? Let's say from Friday, from tomorrow. So what you're gonna get is you're gonna get a homework and a lab. A homework or project some weeks and one lab. So all of these are going to be kind of released midday and Friday, depending on when everything is ready to be shipped. But then when they're due is a little bit different. So labs are due on Tuesdays and homeworks and projects are due on Thursdays. So you have a little bit more time, but homeworks and projects because they're more substantial, and then you have less time with the labs because labs are expected to be completed in like 1 or 2 hours. They come with a pre-recorded video walkthrough that you can just watch the video, do the lab, and then get ready to do the homework. That's how they're structured. Do the lab first, and then you should be able to do the homework using the information that you learn. So again, the first lab and homework is going to be released tomorrow, and then we're going to start this schedule pretty quickly. We also have the scattered office hours throughout the week. So we have office hours on Monday to give you help for the labs, and then we also have office hours on Wednesday, Thursday, and Friday, mostly to give help for the homeworks as well. We have discussion sections. So you have received information about discussion sections, and I'm going to go over the logistics of discussion sections in a little bit, but you should have received a pre-semester form that you can decide whether you want to go to discussion or not. And if you want to go to discussion, what's your schedule? And then we'll allocate a specific discussion time, either on Tuesday after the lectures or on Wednesday. I think we have discussions scattered throughout the day on Wednesday. And obviously, the lectures are on Tuesday, Thursday, and they will be live from here. And then synchronously, you can join Zoom and then participate in the lecture as you probably have figured so far. So lecture attendance is mandatory in a sense that you have to either come to each lecture synchronously and then respond to at least one poll. So if you respond to one poll, you're good. So you don't need to worry about missing any of the polls if you at least responded to one poll. And if you're going to not come to the lecture, you're expected to watch the lecture within 1 week and then respond to all of the questions that we had in the lecture and submit that through a survey. So we're going to share the link to that survey, which has all of the questions a few hours after lecture concludes usually. So watch out for that. And then we'll also release the recordings, I think by the end of Tuesday and Thursday after each lecture. So that's where 5% of your course grade is going to go. There is also anticipation that, oh, after you were sick, you were traveling, there was something coming up 1 week and you missed one of the lectures or a number of lectures, there is also drop that was built in, and you can use your drops if you miss any of those lectures. If you complete all of the lectures and you come to all of the lectures, there's a very small percentage, bonus percentage that you will receive. So if you're trying to collect all of those bonus points, this is a great opportunity for you. So discussions. As you saw in Ed, we have 2 discussion formats this semester. First of all, Data 200 and 200S and 200A students, graduate students don't need to go to discussion. This only applies to undergraduate students, Data 100. So there are 2 versions of grading for Data 100, graded discussion and ungraded discussion. With the graded discussion, 5% of your grade is for you to go to discussions, work on a worksheet with your TA, and just is based on the participation or like attendance to those discussions that you'll receive credit. There's also, I think, 3 drops that we built in. I'm going to show you the exact numbers. 3 drops that built in that you can miss up to 3 discussions and still be able to get full credit on discussion attendance. If you choose to not bother with the discussions, you're still expected to read the discussion worksheet and just know the problems that we worked on for the final exam. So it's still going to be within what's covered in the course, but you can use it as problem sets to get ready for the midterm and final exam. But then that 5% is going to be reallocated to homeworks. So homeworks are going to have a higher percentage. So it, again, depends on how you like to manage your own time, whether you want to go to discussions or not. This is very flexible. With the pre-semester survey, it's very important. The pre-semester survey is going to close tomorrow at noon. So you have to tell us whether you want to go to discussion or not go to discussion. If you choose that you don't want a discussion, discussion will not be assigned to you. You cannot opt in later. If you choose that you want a discussion, we'll assign a discussion to you. You can still go to the first week of discussion, see if you still want to continue or you want to opt out. So you have 1 week to opt out if you originally opted. So, you know, it's a little bit complicated, but ask questions on it and we'll be here to help you. This is kind of to make improvement over the process that we had last semester, and hopefully it will give you more flexibility on your week-to-week schedule as well. Read all of those details. The opt-out deadline is September 6th. This gives you 1 week to go to discussion and experiment. But if you're sure that you never want to go to discussion because you're busy on Tuesday or Wednesdays, just don't sign up initially. Homeworks and projects. There are 12 different pieces of homeworks and projects. Every week, there will be something that will be released to you. Either a homework or projects. The projects are kind of homeworks, but they're longer homeworks that are broken down into 2 pieces. So we have 2-piece projects and 2 of them throughout the course. So you will receive 1 actual, like a kind of an assignment every week to work on. And we're gonna talk about this a little bit more. Labs, I said, it comes with walkthrough. They're gonna be released together. So you have up until Tuesday to work on labs, up until Thursday to work on homework and project. Exams. So as you might have seen, Data 100 is not offering alternate exam. So if you have a conflict with this area that I'm highlighting, October 23rd for the midterm, this is an outside of the class midterm, 7 to 9 p.m., or with the final exam, which is on December 18th, 8 to 11 a.m. If you have a conflict, you need to resolve that other conflict ASAP. Do not reach out to us. We're not able to accommodate any alternate exam in a class of this size. All of the exams are going to be in person except for the Data 200S. Actually, the 200S doesn't have midterm final. Let's strike that. All of the exams are going to be in person for everyone who needs to take exam. Office hours are mostly scheduled in Barn Hall. All the staff office hour in Barn Hall 101B. It's a really fun area for those who are coming from Data 8. You know that there's homework parties always going on there, and there are students that you can hang out with. So please go there. I'm trying to hold one of my office hours there, so you might see me just hanging out there from time to time. But the schedule of office hours, you should be able to see them. And I don't think that we have released it yet. But if you go to the calendar page, on the calendar page, you should be able to see 1 calendar for instructor office hour. You see there's nothing this week, but there might be some next week and then some more also next week, so on and so forth. These are all office hours, and then there's also the schedule for the lecture discussions and the special events such as midterm and final exam should be on this other calendar. And we're in the middle of the lecture, so we know that this calendar, at least so far, has been accurate. So consult with the calendar if you're going to office hours, our instructor office hours, or TA office hours as well, and that would be great. So let's go back to where we were. We were looking at office hours, and we're done with that. Now we can go and take a look at your grading scheme. So find your section, take a look at the breakdown. You see that there are homeworks that all of the sections need to complete. You see 2 columns for Data 100 with discussion, Data 100 with no discussion. So you see that The weighting for the homework is 5% more. Everything else is the same between the two data 100 streams, except for discussion is 5% discussion does not exist. Most of the graduate students are in data 200 or 200A, which this column would apply to you. For students from MSSE program, then you're enrolled in 200S. Just double check your grading scheme as well. And you can also see the drops here that for the labs, we're dropping the 2 lowest. For the discussion and lecture, we're dropping 3 lowest, which means that you can miss 3 lectures and up to 3 discussion sections as well. There's no drop for homeworks and projects. And historically, students complain about it, but we have a way of making you happy. And I'm going to talk about that a little bit here, which is true slip days. Although we don't have drops, but because there are 12 different homework or project deliverables, we are offering 12 total slip days. So you can use your slip days based on your own schedule, if there is any extenuating circumstances that's happening, so you can directly use your slip days without contacting us. This is for you to use. We'll basically take a look at the submission time of your homework, and we will automatically calculate how many slip days you use, right? If you use a slip day, you can't decide that I don't want to use a slip day and go and like grade an earlier submission that I had. As soon as you use it, and it will be deducted from the 12 total slip days that you have. Important note, on every single homework or project, you can use up to 4 slip days. So you can just use 12 of them altogether on one homework. This is mainly because we need to stay on the schedule for grading your homeworks. So that we grade it and we release the solution so that all the students can see the solution. If they're getting ready for the next project, for the midterm, for final exam, we have to stay on a certain schedule. There was one more thing here that if you require any additional accommodation, if there is anything that's happening that's beyond all of these slip days and drops and everything that's happening, we have a form that's called additional accommodation form. Fill it out. A member of our staff is going to be able to reach out to you within 2 business days. Don't expect a live staff responding to you immediately. So wait for 2 business days, and then they'll respond to your request. DSP accommodation. We have received most of the DSP accommodations that we're expecting. If you are expecting to get an accommodation, please have the DSP office send it to us ASAP so that we can calculate or be able to accommodate different pieces of your support. For DSP students, you're going to automatically get DSP students with assignment or homework extension accommodation. You're going to automatically get 2 days extension. You don't need to request for it. If you need anything beyond 2 days, fill out the additional accommodation form, and then we'll be able to help you figure out how we can accommodate your situation. For DSP students, we're not able to accommodate an extension beyond 7 days. This is, again, because we're going to release solutions, so submitting a homework after that 7 days is not practically possible, right? So again, reach out to us. We'll try to figure out how we can best navigate it. One more important fact that is new this semester is that for all of the students, there is a requirement of completing 50% of exams or the projects. The project applies to data 200S students, but for everybody else, the average of your midterm and final exam, the average percentage should be greater than or equal to 50%. This is just to make sure that the amount of supervised work that you're doing in front of us in proctored exam is reasonable with the whole ChatGPT stuff that might go around for homeworks and labs. So this is new this semester. Historically, there shouldn't be an issue. Midterms and final exams are pretty standard. You can see the historical trends. So this generally is not an issue for students and should not have been an issue if we had this policy prior semesters as well. I think that's about it. So I'm going to go back to the slides and talk about different resources that we have in the course. So obviously, you know the course website. The course website is at dtss.org. fall24. So you should be able to find all of the resources that we have there. You will also work on your homeworks and projects and labs on Data Hub. So there is a version of Data Hub for Data 100, and the link is linked on the website, and it's also linked here as well. So if I go to the website and I show you, okay, happening here, so you'll be able to get access to all of these links and these forms that you need. There is Ed for the course, there is Data Hub link, there is Gradoscope, there is the link to the playlist of lecture videos, the additional accommodation form, and we will also utilize office hour queue for office hours in Warren Hall that we will be holding. So aside from that, there is a lecture note, which is like there is one lecture note that is a transcribed version of everything that we teach every lecture. So it's a really good reading resource for you as well. It's also linked here, so you can go here and then see that. Okay, so here we have introduction, lecture, this lecture that we have, everything is transcribed and explained, and so on and so forth. So this is, again, a really good reading resource for you all as well. And there is a textbook that Joey is a co-author of. It's a good resource. It's not aligned with the lecture, but if you have extra time, read it. If you don't have extra time, just read the course notes. Course notes are very closely related to this version of Data 100 that we're teaching. The programming environment that you're using is Jupyter Lab. It's similar to Jupyter Notebooks that you had seen in Data 8, but now it has all of these file management area that you have here, and you should be able to load your data, take a look at your data, and be able to create files and then manage kind of how you want to structure everything that you have. And then you can also have kind of a mini computer thing that you can have multiple windows and then be able to see what's going on in the notebook that you're working on at that given point in time. If you are in Data 200, 200A, 200S, and you haven't seen Jupyter Notebooks before, these are some good resources for you that you can quickly go over and then get used to how this infrastructure is going to work out in Data 100. In Lab 1, you will actually learn a bunch of shortcuts on how to professionally use Jupyter Lab. So that's going to be a really great resource for you, and that's going to be your Lab 1. So just learning how to play with Jupyter Lab. So now I'm going to turn over and talk a little bit about data science lifecycle, because we're going to go over this data science lifecycle and then see different elements of the course from the perspective of which stage of data science lifecycle we're in. Is there a question?
Yeah, just what's the
Okay, question is, what's the difference between Jupyter Notebook and Jupyter Lab? I would summarize it as Jupyter Notebook is a simplified version of Jupyter Lab for beginners. So in Jupyter Notebook, you're not going to mess around with files and managing everything yourself. So there's less functionality. So you have like a plain notebook that you can run through cells and write text cell and code cell and whatnot. But Jupyter Lab, you have more functionality available to you. As I said, like mostly that file system thing, managing all the windows that you can see. And you will have a terminal in the same kind of environment. So you should be able to also use command line if you need. But you probably will not use all the fancy functionalities in Jupyter Lab anyways, but we also wanted you to see the most, like the professional industry standard kind of framework and infrastructure that we need to use as a data scientist. Good question. If there are any more questions, please feel free to ask questions on the Slido because we're a little bit running short on time. Thank you. Okay, what is data science lifecycle? So imagine if you go ahead and Google data science lifecycle and then figure out like what data science lifecycle is, and you're going to get all of these colorful flow charts and whatnot. Most of them are correct. Most of them are explaining the life cycle that any data scientist or data engineer is going through on a daily basis or in a project. But what we're going to work on in Data 100 is remembering this workflow. This is a data science lifecycle workflow in Data 100, which is kind of a high-level description of a data science workflow. So the way that this workflow works is that it has two entry points. So you see these two entry points right here. So a project generally, as for a data scientist, would start either when you have a question and you have a research question, and then the next step for you is to go and find the data and obtain the data. That is stage 2 right there. Or that you have a stakeholder that is going to present the data to you and then say that, oh, we have this data. Would you be able to extract this information for us or help us analyze this data? That's the second entry point, that you don't have a research question. You might want to afterwards go ahead and formulate a question, but then the initial workflow starts with obtaining the data. And then it goes around the cycle. You can see that there are arrows forward and backward, and this kind of shows that this life cycle is pretty iterative. It's kind of very important for us that everything that we teach in Data 100, we're going to tell you which stage we're in. And it will make sense to you why we're going around the cycle and why this cycle is actually iterative. So the first step, so what is asking a question? So when we say that we want to start a life cycle by asking a question, that means that we want to form a hypothesis. What is a research question that we have? Do we know what kind of metrics we have so that once we start the life cycle, we know at what point do we end this life cycle? So these are all the good questions that we can ask when we want to start the life cycle with a hypothesis or with a research question. The second stage is obtaining the data, as I said. So you need to make sure that you have the data and you understand what kind of data you have and identify whether you're ready to move forward to the next stage or not. So for example, in the obtaining data step, we're basically taking a look at, do we have all the relevant data that we want? What are the attributes that we have in our data? What are the biases that might exist in the data? Kind of making sure that the data is relevant, the data has all the attributes that you would need for modeling, and then you're ready to move forward with understanding it a little bit deeper. So understanding it a little bit deeper and understanding the data is the part that we call it exploratory data analysis. We'll spend roughly 2 weeks in Data 100 doing exploratory data analysis, or EDA. This is the part that you will visualize data, you will transform data, you will take a look at whether, again, your data has all the attributes that you want or not. If not, you'll take that arrow back to obtaining the data, you will obtain more data, and then you'll come back. So this is the part that you will calculate whether your data is enough and whether your data is in the right format for you to do the modeling and move on to the modeling phase. This is not modeling yet. And then understanding the word is the part that we have modeling and modeling, which is prediction and inference. In a prediction task, we would design a model that then we can basically use that model in similar settings and similar data sets and be able to figure out how the model is performing and how we can predict on the same task. So for example, if we're going to predict based on some characteristics, whether there's going to be fire in a certain area or not, we could basically use similar data in future and similar neighborhoods that we had data for to be able to do the same kind of prediction. Inference is slightly different. Inference is not going to be the topic that we're going to cover in Data 100, but inference basically is that, okay, if you have a certain understanding of how the word works, how would you make a generalizable kind of statement and apply the same kind of modeling that you have in a more generalized setting? So it's kind of taking one step further, and instead of just doing prediction on the same task, you're doing the inference on relevant task and looking at the implication of your prediction on other domains. Data 102 is going to be the next course to Data 100, which covers more about inference. In Data 100, we're going to see a lot of modeling that we'll do using clustering, regression, classification, and things like that, which is in the area of prediction tasks. So hopefully this will work this time. This is the last slide of the day. So if you haven't responded to any of the previous polls, make sure that you respond to this one, and let's give this a try. Why do you think data science lifecycle is iterative based on the explanation that I gave about all the 4 stages? new insights, more questions. Exactly, once you have new data, you might form new hypotheses. Then based on the new hypothesis, you might want to see, oh, do I have enough data or not? And then collect more data. And all of those things will go around this cycle, and then you will iterate enough up until the point that you're confident, and the report that you're generating at the end after the prediction task is going to be solid and kind of accurate and dependable. Cool. 62 people are still participating, so I'll wait for that number to settle a little bit, given that this is the last slide of the day. And then the next step is seeing a fun demo. Let me go next. Yes, it's demo. And I can just let this be open and then go to the demo. Where can you find the demo? The place that you can take a look at everything that we'll be releasing is actually going to the homepage of Data 100 Fall. And then you should be able to actually see the schedule. So here, for example, we released everything about lecture one introduction, who is going to give that lecture, and then a slide code HTML. So code is going to spin up a Data 100 data hub for you, and then you should be able to actually run stuff. Code HTML, if you're on your phone and you just want to take a look at the code that we posted, you should be able to do that as well. So I'm going to switch here and walk you through one simple example of data science lifecycle. So this simple example of data science lifecycle is that what I want is that I have a bunch of different questions. So the questions that I have is that I'll try to answer through this demo is that I want to see how many students we have in the course. I'm sure you're all curious to see how big this offering is. And then we're going to see what are the majors, what are the top majors, what's the distribution between graduate students, undergraduate students, this distribution of names. So all the fun stuff that you'll get to know about Data 100. And then the last thing is that we're going to take a look at the trend of the distribution of undergrad and graduate students on campus historically since 2013, and the distribution of undergrads and grads in our course, and just compare it with our trends to see if we're within the same, if we're like representative of this trend that we have. So what you're seeing is that every notebook that we will post is going to have a title. It's going to say which lecture this notebook belongs to, and then it will have a bunch of different text cells and code cells. In the text cells, if you read them, it really flows with the flow of the lecture. So they go together really well. So some software packages that we're gonna import are basically like NumPy that you'd seen before, pandas. Next 3 lectures is all about pandas. So I'll be here for 3 lectures teaching you how to use pandas. And then assuming that you will go ahead and learn pandas and learn how to read pandas API documentation. It's gonna be fun. Then we're gonna do some exploratory data analysis, some lectures on EDA, and then we will learn a lot about visualization. So you will learn Matplotlib, Seaborn, Plotly, hopefully in the visualization lectures. And then we are also plotting some few other stuff here too. Okay, for now you don't need to remember stuff. So the first question that we have is, who are students in Data 100? So let's take a look at how I can answer that question. So this question that I'm trying to answer, I need to obtain the data for it. So what I did was basically I looked at the Cal Central. I downloaded all the data that we had from the enrollment of all 3 sections of the course. And what I did was that I tried to anonymize it, add a little bit of noise to the data, noise in the sense that, okay, I have only your first names and not last name, middle names, and majors also is there. So I have 2 separate spreadsheets of majors.csv and names.csv. These are pre-processed notebooks that you'll see. Where are they? So you should be able to see them in the data. So you should be able, so this is a different version, but you will see majors.csv, names.csv. You will only be able to see these 2 spreadsheets or CSVs and not the rest. So what I'll do is I will load majors.csv in a data frame called majors and names.csv in a data frame called names. And then we'll basically take a look at the data and try to understand the data. So this is how the flow of processing a data or responding to one data science question looks like. So how do I start understanding the data? What I can do is I can just take a peek at the data. So head is going to give me the top X number of rows. So here I'm saying that head 20, give me the top 20 rows in this spreadsheet. And again, because they are randomly kind of ordered, this is just going to give me the top 20 kind of majors that we have. So you're seeing that, okay, the person that was represented in the first row is from letters and sciences, undeclared, so on and so forth. So you should be able to see that in majors data frame, this is a data structure. You have majors and I have terms in attendance. So that's why we take a look at the data. We want to see attributes. We want to see how many rows we have. And then we want to generally see the structure to see if the structure is within what we're expecting or not. I can also do the same thing with head of the names. So I'm looking at the top 5 rows of the name data frame. So the name data frame, you can see that it has 2 different columns, the name column and the row column. So it says that the role of all of these top 5 people is a student, and then you have some of their names. And you might notice that they're not all in the same format. Ethan, James is all caps, and then the rest are title case. So I need to fix that as well. So just generally taking a look at the data will tell you how you should clean it. And that's why we spend a lot of time in cleaning. We'll clean, we'll visualize, we'll again think that there's more cleaning that we need to do, and then we'll go around this cycle again and again. So how do I resolve the issues of these names being in different formats? What I can do is I can go ahead and say that, go ahead and get the names column, go ahead and assume that this is a string, and just lowercase that a string, right? So this is all of the things that you're going to learn in the next 3 lectures are kind of condensed in the first half of this demo. So I'm going to do that, and then I'm going to take a look at those names again, and now James is in the proper format. Everything is lowercase. This is helpful when I want to aggregate based on unique names. Then I won't have an instance for James all uppercase and James all lowercase and James title case, and then treat them as different names, but in fact they're similar, right? So now take a look at the names data set. So in the names data set, what I want to do is I want to kind of generally understand whether the distribution of my data is right or not. So what I'll do is I'll say that, okay, go ahead, get the names column, get the first character of that string name from every row, and just calculate the frequency of each one of those first characters. So for example, if you take a look at what it looks like, it will tell me that, okay, if I'm looking at the distribution of the first letters of the names, the most frequent one is A, names is starting with A, and there's 200 of such names. There is the second one, J, 118, and so on and so forth. And I just looked at the top most frequent first letter occurrences, right? So that's why I'm only getting 5 of them. What I do is I'll basically say that go ahead and plot all of them together, because then visually I'll understand it better. And then you'll see that A, J, S, and then all the way, all of those first letters that are appearing in your names. And you can see that A and J are the top most frequent names. And we can validate with our knowledge that in the United States, J and A names are the most popular first initials. So that's kind of validating whether your data comes from the right distribution or not. This is a very naive way of doing it, but you'll do all of these like extra information that you have in order to validate whether your data has the distribution that makes it reasonable for you to use for the modeling purpose or not. So you were asking how many students we have. So you see, if I get the lengths of each one of those data frames, the lengths are the same, and there are 1,201 students enrolled in the course. That's how big this course is. It's exciting. It's a slightly smaller than previous semester, believe it or not, but then there's 1,201 students in the course. So let's understand the roles a little bit better. So we'll keep going. So you'll play with any data set that we'll give you for a while, and you'll see me do that with this data. And every time that I will give you one insight or one information about the data, you will learn something about the class that you didn't know before, right? That's what makes it a little bit also fun to go through the data as a part of this process. So I'm gonna take a look at the roles and then I'll say that, okay, give me all the unique roles. And it will tell me that there is 1,200 instances where the role is a student, and there is one instance that the role is this hash ref exclamation mark. And it shows that, oh, that hash ref exclamation mark might be a faulty row. So we should go ahead and remove it. How do I remove it? I would say that go ahead and show me that row. It shows that, okay, the row 1133 is kind of malformed. And then what I can do is I can say that go ahead and filter for every word that the name or the role is not equal to that hash ref. So we'll do that. And then we'll basically take a look one more time. And now I only have 1,200 students. See, we initially thought that we have 1,201 students, but then we lost that one student at the end. So hopefully don't drop the course. Or if you're dropping, drop with multiples of 10 so that we can still like have this nice numbers of the students who are taking the course, because I'm kind of obsessed with that. All right, let's take a look at the names, right? So going through the names, so I'm going to take a look at the most frequent names, right? So I say that, okay, give me the frequency of the unique names and structure it nicely. So 2Frame says that it's structured as a data frame, so I can visualize it nicely. And we can see that the most frequent name is Ethan and Ryan and Daniel are tied at the top, right? So let's do a hypothesis. So this is where you would do some hypothesis. You would say that, okay, if you're assuming that it's equally likely for one Ethan, to be in the lecture or be synchronous online or just not bother attend the lecture, then we have 3 possibilities. If they're equally likely, I'm expecting 3.3 Ethans be in the lecture hall. So raise your hand if you're Ethan or more. 1, oh, give me 3, 2, 3, and it should be one more. 4. Oh, there's one Ethan online. Okay, that's fun. Okay, great. So it was more likely for people to be attending the course, either synchronously or asynchronously. Sorry, I said that in the course. I still didn't meet that 3.3. But still, you see that like we as data scientists will try to form hypotheses. My hypothesis was that the distribution is uniform between these 3 possibilities. We're going to take a look at all of these probability jargons a little bit later, and it's going to be more fun, but we're going to take a look at it from a data scientist perspective, not from like a statistician perspective. And no disrespect to statisticians. But anyhow, so let me continue because we still have 5 more minutes and I want to show you more about the course, right? So I'm going to take a look at the columns in the majors data frame. So remember that I had the major itself, I had term and attendance. And if I go ahead and take a look at the frequency of term and attendance thing, you should be able to see that majority of the students, not majority, sorry, the highest frequency of term in attendance is 5. Raise your hand if you're an undergrad in your 5th semester. Yeah, so see, this is kind of, oh, okay, there goes online. So this is, we have 479 students in their 5th semester. We have all of those semesters there. There's that faulty row of hash ref exclamation mark that I still need to remove. There's also G. What's your guess about this G row here, 112? Graduate students. We have 112 graduate students. That's a small, tiny, intimate group because they're going to do a grad project and they're going to need more kind of hands-on supervised help throughout the course. So I'm going to go ahead, remove that ref thing that we said, and then take a look one more time. Now that ref record is not there, everything else is the same. If you go ahead and sum up all of these values, it should add up to 1,200, the nice enrollment that we have established. We can also summarize data. See, with a simple function call with describe, I'm taking a look at, okay, what is the summary of this data that we have? So it says that for name and role, there are 1,200 records in each one of them. So we know that already. It also says that there are 862 unique names. So your names are pretty unique because out of the 1,200 students, having 862 unique names is pretty cool. And then the role is only one because we only have one role as a student. The top name was Ethan, and then the top role frequency was a student. And the frequency of this most frequent name was 10 that we established it already, and the student is 1,200. Remember that we had top 3 names, but now only shows Ethan. This is because it basically initially, I think, sorted it based on alphabetical ordering or something. So that's why Ethan won it. But I have to take a look at why that's the case. For majors, you might have guessed that the most frequent major is letters and sciences under undeclared undergraduate. And how many of that we have? We have 267 undergraduate letters and sciences students. With the term and attendance, we saw that 5 is the most frequent, and then we have 479. So we can keep going and taking a look at, okay, what are all of these majors that we have? We have letters and sciences as most frequent, CS folks as as the second most frequent, EECS the third one, and then you can find also your major hopefully here if you go down the list. If we go ahead and visualize all of this thing, you see this pretty cool plot. We're gonna learn how we can plot all of these stuff. But take a look. I hover over it, it will show me that value, and then it will show me the count. This is how we can plot the stuff with Plotly. So we're gonna see more of these in the next few lectures. I'm gonna let you go through this demo on your own pace. There is this last piece that goes ahead and takes a look at the trends of undergraduate versus graduate students on campus over the years. So it's gonna be fun. I will see you back on Tuesday. Happy holiday weekend.